Hey guys, so today I'm going to be going through the process of creating G-code to machine one of these little parts out of aluminum on a 3-axis mill. So to start off right off the bat, it's important that we get out of the design environment on Fusion 360 and move to the manufacture environment. The next step is to actually go through the setup process. So when we machine this part, we need to be able to tell, in this case, we're going to be using a Tormach mill, to tell the mill where the part is in 3D space. To do this, we're going to go to Setup, New Setup, and we're going to go to Stock really quick. And this really depends on your part here. For the sake of simplicity, I'm going to go to Fixed Size Box, and I'm not going to have any rounding happening, which means our initial stock actually matches the external dimensions of the part we're going to machine. And that looks good. We can continue to set up. Now in setup, machine, we can select this later. For the setup, we are going to be milling. And so the important part comes with our work coordinate system. And we're going to select a box point to indicate, this is the point that we'll actually indicate in on the mill that we're going to be using. And it's really important that at this stage we have our X, Y, and Z axes correctly orientated. So typically in a mill, your Z axis is going to be your height. In this case it is. And the Y and X axes are in their correct positions. However, if they do not end up being in their correct positions, you can always change this by going to Model Orientation, select X and Y axes, or a Z axis and a plane, and go through those steps to actually correctly orientate your coordinate system. But we have that correct for now, so we're going to continue. And of course our model, we've already selected the body, so we're good to continue. We're not going to have any fixtures for this part. It's going to be clamped in a vise. Alright, so now that we're done with setup, if everything was done correctly, we'll see a little green check mark next to our setup parameters. Now in this setup stage, we're going to move on to our first operation. Now, if you notice, this part actually has a milling operation that goes all the way through it. And so that is what we're going to focus on first. So to continue, we're going to go ahead and go to 2D Pocket. From here, we're going to select the tool that we'd like. Now, Fusion 360 should have an inbuilt library of milling tools. If we go to Milling Tool Inches, we should be able to find, in this case, we're going to use a 3/16 flat end mill. And once we have that, I wouldn't worry too much about the cutting presets they have below, because we're going to adjust the speeds and feeds ourselves. So let's go ahead and click Select. And that's perfect. We have our little tool in there. If we go to Geometry, which is the second tab over, it's asking us to select the pocket that we'd like to machine. And so to do that, we're just going to get a glance over here. We're going to select the bottommost pocket. And from there, we're going to go back to Tool. For the feed and speeds, I'm going to use values that I know work with the machine that I'm going to be using. However, there are many resources online that will help you select these feeds and speeds based on the material you're cutting and the tool that you're using. So this is, I believe, going to be 6061 aluminum, and we're using a carbide 3/16 end mill. So from experience, I know that a surface speed of 150 feet per minute is going to do the job for us, and a cutting feed rate, well actually in this case we're going to set it to be a feed per tooth of 0.002. Right, that's great. And something else to mention actually, so we haven't actually specified if our tool is going to have 4 flutes or 2 flutes, and that is something we can actually edit. So if we go back to tool selection, we can click this little edit icon up here, and in this environment we're actually able to change the length of the tool we're using if you need to. So we have 3 flutes as the number of flutes that we're using, but we're actually going to be using a 2 flute end mill. So I'm just going to go ahead and select 2 over there. Yeah, and all the other values should be okay. Just go ahead and click accept. Yeah. All right, so once you change your tool, even the slightest, you need to re-enter in your feeds and speeds. So 150 surface speed, and we're going with a 0.002 feet per tooth. Perfect. And so before we continue with this, we're not done. Just want to simulate what we have so far. If you right click on the 2D pocket icon, you can go ahead and go to simulate. So just to make it a little clearer. And we can adjust the speed of the simulation with this bar down here. So it looks pretty good, although we might want Alright, so that looks pretty good. A couple things I'm noticing though is that we still have an offset of material that we need to take out, and we should ideally add a few more passes and we should actually have the tool go through the bottom by a certain offset, just so that we have no material remaining. Alright, so we're going to exit that simulation. Go back home. We're going to go back to our 2D pocket, edit it. Now, over here, we're going to go ahead and go to our heights. And the first thing we're going to go and do is our bottom height. So I'm just going to go to selection. I'm going to go ahead and select that bottom. And we're going to do an offset of about 50 thousandths of an inch. Of course, it's important to remember that when you set up this part in the vise, or however else you're planning to set it up, you have to make sure that you have nothing holding the part underneath this gap. And then if we go ahead and go to passes, we'll see that we actually did have stock to leave on. It was leaving 20 thousandths of an inch in the radial direction and 20 thousandths of an inch in the axial direction. We're gonna go ahead and uncheck that. That only really matters if you're trying to differentiate between roughing passes and finishing passes, which is not something we're gonna focus on right now. And finally, we're gonna go to multiple depths, and I'm just gonna go ahead and go with a 20 thou maximum roughing step down. Of course, this is playing it quite safe. Gonna simulate. And that should look a little better. Yeah, that's perfect. So I'm just going to go ahead and make some final edits. I will also say that if you go back to simulate, you can actually see how long this operation is going to take. So machining time, it says 33 minutes. It's obviously quite a bit, and this operation doesn't need to be nearly as long. So we're going to go back, we're going to edit our passes. Maximum roughing step down, we're going to change that to 50 thou. That looks good. And heights, we're gonna change the bottommost height to 20 thou below the bottom face. That should be a little better. Yeah, that looks much better. And of course, as a sanity check, it's always important. You always want to make sure that you know, you're never going to come in contact with the shaft that's actually holding your end mill. And usually if this happens, you know, Fusion will throw an error, but it's still important to double check that you have the correct lengths actually set up in Fusion, so it can throw you that error. All right, so that's our first operation done. And so yeah, let's move on to our next one. So the next one is actually also going to be a 2D pocket. And we're going to be removing this second part of the material. So we've already selected our pocket. We go over to heights. We don't need to do an offset here. And if we go to passes, again, we're going to uncheck stock to leave, go to multiple depths, and just give ourselves a 50 thou max depth of cut. If we go to tool, right, so this is the same tool that we used last time, so it's going to remember the feeds and speeds we used. That looks good. Just go ahead and click OK, and let's simulate that. Yeah, that looks pretty good. So you will notice that it had a slightly different way of actually moving the end mill into the part in a helical fashion. You can actually change this if you'd like to by just going to linking, and there are all types of ramping transitions that you can use. I'm going to leave it as helix for now, just because it works for our purpose, but if you are really looking to save time, you can play around with those settings a little. All right, and then great. So the next part we're going to go to is actually focusing on this hole. So we are designing this hole to actually have threads for 1/4 20 bolt, which is right hand threaded. And so to do this, we have to do it in 3 steps. One is center drill, then drill, and tap. And we're going to do all 3 of those with the drilling operation. So if we go to the top up here and go to drilling, quickly select that. And for spindle speed, I'm actually going to go down to 2000 RPM. Again, this is based on values that I've used in the past, which I know work. And we're going to go to a feed rate, a plunge feed rate of about 12. If you want to figure out these values for your machine, again, just go online. There are many calculators that can do it for you. Now if we go to geometry, it's asking us to select our hole. It's a pretty straightforward selection. And if we go to our heights, again, we might want to actually, so because we're using a center drill, let me actually put in that center drill. So if we go to hole making tools, inches, and filter for center drills, we can use the number 2 center drill, which is going to be good for our purpose. Now you can see it's clearly plunging the center drill all the way to the bottom, which is definitely not what we want. The purpose of the center drill is to create the start of the hole so that our drill bit does not waver across the surface of the material. So what we can do to fix this is just go ahead and we're going to focus on our bottom height. I'm actually going to select the top face for this and then offset it by, let's say, 50 thousandths of an inch. That looks pretty good to me. And just going back to tools, since I changed the tool, our values did reset themselves. Yeah, I'll go with 13 inches per minute is what it's recommending for this center drill. And based on that, we should be good to go. For this type of cycle, doesn't really matter right now because this is just a center drilling operation. And we have a green check mark, which is perfect. And we can go ahead and simulate that. So yeah, that was pretty quick. Just a quick side view. Yeah, that's perfect. All right, so exit that simulation. Moving on, we're going to go back to drill, and now we're actually going to drill out the hole. So because the hole is small enough, we're not going to step up in drill sizes. We're going to go straight to the drill size we require for the tap that we're using. And you can find these drill size tapping charts online for the fit that you're looking for. The drill that we are going to be using is a number 7 drill for a 1/4-20 tap. So go to our library again, go to hole making tools, just filter by drill, and just gonna find our number 7 drill. Should be right there. Perfect. I'm gonna go ahead and click select, and spindle speed, again, gonna go to 2000 RPM, and I'm gonna go with a more conservative plunge feed rate of about 15 inches per minute. That's also because we're drilling all the way through. I'm actually gonna go ahead and go to cycle type and go to deep drilling full retract. So these are fairly conservative settings, just to be clear. The reason what the cycle does is that it'll actually drill about 50 thousandths of an inch in and then retract all the way, just to make sure that there isn't a buildup of chips. You could probably do it without the cycle type, again, just being a little careful here. Right, so then after we select our tool and cycle type, we can go to geometry, and the whole face is the same. However, you can see that because the end of the drill bit is tapered, we do need to go past the bottom face in order to drill a hole all the way through. We're going to change that by just putting an offset off the whole bottom. So not 50 thou, maybe 100 thou. That looks good. Yeah, that looks good. Oh, we could also, instead of doing an actual manual offset, is just select drill tip through bottom, which will also work just fine for us. All right, just to double check our settings. That looks good. I'm gonna go ahead and click OK. And perfect, we have a green check mark. You can take a look at what that looks like. Yeah, that looks good for our purpose. So moving on, we have the final step of this tutorial, which is actually tapping, and which actually might be the simplest to set up, because when it comes to feeds and speeds with tapping, there isn't much play. It's very, very precise. And so we're just gonna go ahead and click drill. We're gonna select the tap that we want. So it will be under hole making tools. We filter by right hand taps. We're gonna find our 1/4-20 tap. Just click select, and you'll see that it just gives us a default preset right off the bat for the spindle speed. We're gonna go ahead and, yeah, we're not gonna change that. I should note that on the mill that we're using, we have a special collet, a spring-loaded collet for tapping purposes, just because tapping with a rigid collet will usually result in many broken taps. But nonetheless, we're going to stick with these feeds and speeds. For geometry, again, we're going to select the same hole face that we've done. And depending on the tap you're using, whether it's a bottoming tap or a tapered tap, you might want to actually give a fair amount of offset. So I usually go with about 100 thousandths of an inch to 200 thousandths of an inch. We'll go with 150 thousandths of an inch just to be safe here. And go ahead and click OK. We should be good. Let's take a look. Yeah, perfect. And that's pretty much the 5 steps that we're gonna use to make this part. If we want to simulate the entire operation, we can actually go ahead to setup 1. Just right click on it, go to simulate, and click play. So we have our milling operations that take precedent, our drilling operations, and our tapping operation. Right, and if we look at the statistics, total machining time is going to be just under 20 minutes, which isn't too bad. That's pretty much the tutorial. Thank you for watching, and I hope this helped you out.